Right, we're back working on confidence intervals for means. And this is question 7. It says you intend to estimate a population mean, mu, with the following sample. Here's our sample. You believe the population is normally distributed with, find the 90% confidence interval. Enter your answer as an open interval, accurate to 2 decimal places, because the sample data are reported accurate to 1 decimal place. So here's our 90% confidence interval, and notice it says, don't do any preliminary rounding. Confidence critical values can be rounded to 3 decimal places. I just prefer to let Excel do all the work. So I'm going to just grab this data set and bring it over here, and I'll paste it. I like to use special in case there's a chance one of those things just doesn't come out right. So here is our data set, and there's a couple of things to know. We need some stuff. If I grab it here, I can count here. N is 12. So I can just figure that out from grabbing it and letting it do the counting. Now, we have some stuff that we need, and we're not really given a lot other than a confidence level of, I like to make mistakes there, 90%. And that lets us know that our alpha is going to be 1 minus that. Not new news necessarily, but some news. So here we go. And I probably should have left a little bit of room here so I could find out my alpha over 2. That's going to be equal to now this guy divided by 2. And if I want my degrees of freedom, it would be n minus 1. And degrees of freedom are useful for finding our critical value. So I can do all of this work right here. And the idea, hopefully, is that we're getting pretty good at this stuff and understanding the process. So again, we're working with a t-distribution here, so it's going to be a t-inverse. I'll do 1 minus the tail area. That gets me that right-hand side. And then the degrees of freedom, and I can just click on that. Again, if you don't like to find your degrees of freedom, you can use n minus 1 also. Now, I'm asking you to draw a picture, and I didn't yet, so I probably should. Here I've got my t-distribution. I've got my little errors here, my t-score somewhere over here, and this, and this. I don't like 2 touches there. Are my alpha over 2s, the little tail areas. So I'm going to call this 1.7, gross 96. Anyway, I'm not going to use the rounded value there. Again, those are supposed to be kind of rough. This is pretty rough here. So the rest of the stuff we need to know what the standard deviation is, and we need to know what the mean is. So x bar, we're dealing with a sample here. Going way back to maybe the first module, the average of this data set. This is our mean. And then we need S, the standard deviation of the sample. So standard deviation of the sample, and grab our data set. So we have our critical value. Give a little room there so you can read it easily. We need our standard error. And the standard error is the critical value, the standard deviation divided by the square root of n. Took a little while to hunt through it. So my lower limit and my upper limit. My lower limit is going to be the mean. I just found my standard error. I need to find E. Don't get ahead of yourself, John. Okay. Well, the margin of error is the critical value multiplied by the standard error That's going to be my E, and I need to add and subtract that from the mean here. Okay, so now, back where I was, the mean minus the margin of error. This is our lower limit. And the mean plus the margin of error here for the upper limit. Now we need to write this. Enter your answer as an open interval accurate to 2 decimal places. Now, accurate to 2 decimal places and rounded to 2 decimal places. Oh, I don't know why I started with an 8. The lower limit is 23.879. So that 8, and then the 8's going to round up, put this guy in here. 41.853. So there we go. And sometimes I find it a little confusing, accurate to decimal places and rounded to 2 decimal places. So oftentimes you can round it. You might go accurate if the rounded one doesn't work. And if you think you have all the work correct and it just did it wrong, which occasionally happens, feel free to message your work and the question, and I can take a look at it and make sure you get credit for what you have here. So again, I wanted to do this question because we have a data set, which is kind of new to us. We haven't found the mean and the standard deviation of a data set in a while. But it also kind of feels like we don't have enough information. We have to go find out what we need. So that formula sheet you have, you might want to start keeping it handy because we're going to start using a lot of the things on there. So we found our data set. We took our data set, and our confidence level. Our confidence level used it to find our alpha, then our little tail area, alpha over 2. The degrees of freedom, we just used the function where we just grabbed these guys and counted them up here, like this. Didn't actually use the count function, but you can just see it counts to 12. So I put in 12, the degrees of freedom, 1 less than that. Use our degrees of freedom and our alpha over 2 to find our critical value. Again, we're looking for the area to the left, so it's 1 minus that right tail area. Anyway, then we use the functions in Excel, the average function to find the mean, then the standard deviation of the sample, grab the data, found that, did find the standard error by taking the sample standard deviation and dividing by the square root of n. Almost forgot this step, a couple along the way. Find the margin of error by multiplying the critical value by the standard error, get this guy, and then we subtract it from the mean to find the lower limit, and we add the margin of error to the mean to find the upper limit, round those to 2 decimal places, enter them in here. So I think that's basically all of the types of questions. You might have to read some different context and get some bigger or smaller data sets. Please let me know if you have any questions, and good luck on section 6.1.